Hey, afternoon everybody, how we doing? We're back live again. We're back live again. Whew. Well, a bit later today. Actually managed to get to the boot sale this morning. Absolutely nothing there though, just ended up with a couple books, that was all. A couple books and a bacon butty. Oh well. They come back and clean the chickens out, so chickens are nice and clean now. Mrs. Cruncher is going to go and put some more sawdust in a bit, and they are good to go. How are we doing then? We got Theo in first by the looks of it, Theo. Tony, thanks very much for the super chat, mate. Straight in. He's busy today, but he's hopefully going to join later. Catch you later, Tony, if you are listening. Mac Vision, hi Mac Vision. Brian's in, hi Brian. And Paddy, hi Paddy. Colin's in, hi Colin. Hour later gives you a bit more time to do a few bits then, Brian. Final project for your previous company. Aston's in, afternoon Aston. And Rolf, just finishing Yorkshire pudding and sprouts. No, we have our roast in the evenings here, mate. So I can do the live stream. I don't think we're doing a lot of streaming on a full roast in my stomach. Luigi, how are you, Luigi? Keith's in, hi Keith. Phil the Power Taylor. Chocolate mousse, Luigi, very nice. Benji's there, getting a brew. Afternoon, Anthony. Michael's in. Plymouth have got an RT22 to give away on Free Cycle. Grab it, mate. Grab it, even if it's no good. It'd be all right for spares, wouldn't it? For nothing. Hell. Brett, how you doing, Bretsky? Barry's in. Hi, Barry. Another afternoon of cap bingo. I'm not sure. I think it could be. We'll have a look at this, but I think it's potentially a problem with the capacitor in this radio. Dave Rhodes, how you doing, Dave? I'm wondering if you've got that FRG 7700 any further, Rolf. How you doing in capacitor hell? Doug's in. Hi, Doug. And Tony's in. Afternoon, Tony. How are you? Multi Towers. Hi, Multi. Harb as well. How you doing, Harb? You got there. I think Harb was having problems with notifications, but there's no surprise there. So normally I'm on around about 2 o'clock on a Sunday, but you know, I'm normally on about 2 o'clock, but unfortunately today, as I say, been down to the boot sale and also been cleaning the chickens out. Unfortunately, anybody that's got chickens this time of year, with the damp and the heat, they get red mites, and they're horrible things. They lie in waiting, and then in the night time when the chickens all go to roost, they just go and feast on their legs and that. Not very nice at all. So I've had to go and give them a good old scrub out, spray some insecticide in there today, and hopefully that'll sort them out for another month or so. Richard Milliken, good afternoon to you in Anglesey, Richard. Welcome, mate. Rolf's still recapping. And Michael saying that 10 something this morning, so you missed it. Oh, it's a sod, isn't it? Yeah, I don't think that probably didn't hang about for long. So yeah, today we've got this radio has come in. It's actually come in via Richard from UK CB Radio Servicing. I think a chap is a friend of Richard's and asked Richard to look at it. And Richard said, well, I don't really do that sort of stuff. Give Graham a shout. So he emailed me a while back, and I was like flat out at the time with repairs, so I said I can't really take anything in, but to drop me a line in a couple months, and I've now got it in ready to look at. So hopefully it's not going to be too big a job. I've not got a lot of repairs left now. I've just finished the other Hunter. That's all finished. So those of you on Patreon will have seen the outcome of that. Set up the quiescent current, done the amplifier, and sorted out the problem in the IF, which turned out to be a capacitor again. And all the caps are here, so there was a couple 6.4s in the IF strip that had it gone high ESR. That's all done and dusted, so that'll be on its way back to Rob. What else have I got in? I've still got that damn AOR SR2000 in, which I've got to try and get done. I mean, it's an endless nightmare, that radio. And I've got 2 airband radios for Darren to do, so they're next really. This one's sort of jumping the queue a little bit because it's fresh in, and it might be an easy fix. Touch wood, it might be an easy fix. You never know. So let's have a quick look at it then. So there it is. You'll have seen it on the cover shot today, which I eventually got going. Took me a while, but yeah, it's I mean, Grundig's usually a quality make. This is one of their later models. I don't know when this would have come out. It's probably 1980s, 90s, something like that. I'm not 100% sure. I have got some info on it, so I'll have a look in a minute. I've managed to download a few bits and pieces. So the issue with this is it just doesn't work. And I've confirmed that. It doesn't work. I did try plugging it in the other day. Well, I didn't try. I did plug it in. It's got quite a few bands on it, actually. It's actually got 6 shortwave bands on it. So for those of you like myself that work in megahertz, it goes from 6.3 megs right up to, well, it's probably 6 to 18 megs. There's a little bit of a gap between 7 and 10 megs. Yeah, there is some gaps in it, but overall it's not a bad little radio. I don't 100% know the story on this one, but you know, the owners, I think, I'll have to have a look on the email, but I think it was one that he said for many years got passed down to him, I think. But yeah, it should be a fairly capable set. It's got analog tuning on it, so there's nothing too complex in there. Just going to be different filters for each band, I would have thought. So we've got 6 shortwave bands, long wave, medium wave, and FM. It's got U, FM. So it's unusual in that you've got to push one of the buttons to turn it on. One of the band buttons turns it on, and then pushing the AUS button turns it off. So this is our band selector for shortwave, 1 to 6. It looks like we've got tone control and volume. Tuning manually on the side. FM goes full scale, 88 to 108. Looks like there's been a bit of rust, possibly leaky battery at some stage. Made in Taiwan, as I say, it's a Yachtboy 300, and it's got an FTZ number of U101. So I think that's the actual model number. The model name is Yachtboy 300. Germans do that for some reason. They've got 2. They seem to have 2 model names for every radio. So though it's a Yachtboy 300, it's a U101 version, because there is a different Yachtboy 300 with a digital display. So let's get it plugged in and have a look, shall we? So what we're doing, that radio was last made in 1982. Oh, well, I did say 80s, 90s, so I wasn't far off. Nasty caps, I think it is. If we have a look at the schematic in a minute, there's a cap right across the supply to it, right across positive and negative. So I'm sure that one is has had it. Know your capacitive reactance. Then you'll understand why bad capacitor can cause IF problems. Capacitive reactance. That's a word I haven't heard for a long time. Theo, going back to my amateur radio training days, that is. Capacitive reactance. Yeah, basically that was the issue in the IF for the Hunter. If you remember, when we tuned through the bands on the Hunter, although it was tuning all of FM, you couldn't get a quieting. You know, it was always had a bit of background hiss in it. And certainly replacing the caps in the IF strip cured that 100%. I thought it might have needed the IF trim, and I thought someone had a go at it, but they hadn't. And all the original rubber was was still supple. It hadn't dried out. So there we are. Right, let's hook this up then. Let me have a look. What are we on here? I think we're on 18 volts at the moment because I was working that. We certainly don't want 18 volts. It's 7.5 volts. It's a bit of a strange beast. And it's center pin positive, I believe. We'll soon find out if it goes bang, won't we? So I'll just put it on the edge of current limit just in case I do get it the wrong way around. Because, you know, it happens. There we go. Let's just hook up. Plug in. Yeah, okay. Well, I'm plugged in, I'm turned on, and the set is actually drawing 120, it's actually climbing. So I'm going to turn that off. It's up to 200 milliamps now, so something is definitely shorted on this. Khaled, how are you? You're sure the caps are okay, Khaled? Oh, welcome, mate. If that's how you pronounce it, apologies for bad pronunciation. So it's definitely got an issue on it in the power supply section. So let's have a look at the schematic on it. So 120 milliamps and climbing is drawing way too much power. I would expect it to be about 20-30 milliamps max, really. So it's quite a way out. Where are we? No, that's not that one. Is it that one then? No, absolutely useless. Let's close that. Let me get the schematic up. Okay, here we go then. So this is dated October 81, look. All in German. I don't read German, so unfortunately we'll have to leave it at that. But you can get the gist of it. I don't know whether that's the actual FM. 10.7. Unsure what that means. So this does cover the 300 and 400. I'm not sure if the 400 isn't the one with perhaps the digital display or not. I'm not sure. So nice alignment layout. Looks like we've got the old polyvaricons in this one. They can be an issue. And here's the schematic. If we get it the right way around. Okay. Right. Power supplies down here. Okay, the Yachtboy 400, by the looks of it, it's got a transformer in, so I think that's the difference. It's probably got a built-in power supply, I would have thought, because it seemed dotted. Let's zoom in a little bit. So this is our power supply. This is where I've just come in, 7.5 volts. So band selectors, switch it on. It looks like this is a positive rail at the top here. So I was thinking probably this one, C84. 1000 microfarads at 16 volts, whether that one's shorted and it's pushing the power to ground. It could be any of these. I mean, that one as well. And this one. So I would say the issue has got to be in here somewhere, because it could be this diode. But that diode does some sort of rectification. I'm not sure on this part number, but it's obviously a Zener diode. That's our volume control. And we've got some resistors in here. Sorry, resistors? Where's the goat? Transistors. So I would think the fault is somewhere in here. And say it could be one of these diodes potentially, but I've got my eye on the capacitors. Let's get back to me chat then. Afternoon, Harvey. Could be bad transistor, Khaled saying. Yeah, it could be. It's not doing anything, basically. It's not doing anything, Harvey. Welcome, mate. Pardon me. Battery's still in there and it tries to change. There's no batteries in there, Tony. So basically, nothing's happening. I've got a little bit of hiss from it, but it doesn't really increase with volume, and it's drawing too much current, Harvey. It's drawing 120 milliamps and rising. Nigel, how you doing, mate? I haven't heard you for a while, yeah. Not been live for a while. Had to catch up in the evenings. Have to get some tips on your fence panels. Yeah, get the old post buddies in there, mate. Always have to be suspect of reverse polarity in any of these wall wart sets. Yeah, you are right, Doug. It could be. It could have taken out one of the transistors. So I think it's time to get it apart. Actually, no, it's time for me to grab a beer because I'm absolutely parched here. So I'm going to get straight in with a cold Guinness. So I've just come in from doing the chickens and I'm a bit knackered. It does take a while to pull all their coop apart. Broken Wi-Fi chip. Afternoon, Simon. Yeah, I'm going to open it up. I need to get some beer in me first, Theo. Current overload. Feel the PCB for warmth. Cheers, Tony. Of course, the Germans don't use the same transistors as we used to use over here, so they're all weird types. I won't have the exact transistors, but we might have some equivalents. Cheers, everybody. Oh, very nice. Right, let's have a look then. So how do we get this thing apart? Got a screw in there, we got a screw there, screw under there. That's probably it. So let's commence. I mean, it might jump out and bite us as soon as we see it. It might jump out and reveal itself, the issue, as soon as I take it apart. Probably one of these sets that clips in. Let's make sure we haven't got a screw underneath the tuning control. No, we haven't. Anything in underneath the aerial. Another favourite place to hide them. No, we don't seem to have there. Oh, that was easy enough. Right, and with it being a Grundig, it should come out fairly easy, I'd have thought. What we don't want to do is ping the dial cord off. Probably got to take this knob off here. How on earth you're supposed to get out of that to take it off, I do not know. How are you supposed to get your fingers on that? Cool. Got it. Okay. We're in. We are in. Let's have a closer look. Let's get you in on the overhead camera. Let's go in. Sort the light out. So I'm going to look for bulging caps. I assume this big one here, just out of shot, is the 1000. Pretty rubbish caps, mind you. So nothing really obvious there. Got to be careful because I don't want to let the current run away, because it will invariably take out one of the transistors. So let's get the old goggles on and have a closer look inside. See if anything's vented itself. These caps don't look to be too bad. They're really cheap capacitors though. TK 85 degree. Just looking if any have got any sort of shrunken back wrapping on them that they've got hot. They don't appear to have. What's this thing here? Oh, okay, there's some sort of thermally connected diode there. Seems to be connected to that transistor with some nasty looking gunk. Just get you in there. It's a bit bright in that. So I'm looking at this thing here. So this on the board is saying it's D11. So we've got a diode that looks to be connected with some thermal grease to that transistor. Very strange, a bit Heath Robinson that, isn't it? You know, I'm still hedging my bets on this one. Just out of a shot, I'm still hedging my bets on this 1000 being duff. It's got all that horrible conductive glue stuff all over it as well. I don't know if you can see, well, you can see it there, but it's definitely on the board over here as well, in underneath this cap. We've got it on this cap back here to this resistor, and it is gone quite a darkish colour, so So I think what we'll do is we'll set the current limit and hook it up and see if it's anything getting hot. So let's have a think. What will that? It should be able to hold 100 milliamps, no problem. Just find me other leads, and I'll just set a current limit. That's one thing about this power supply; it's not got like a current limit setting on it. Rob, how you doing, mate? Connect your audio probe on the volume control just to see if it gets that far. Yeah, good point there, Harvey. We can certainly check if the amplifier circuit's okay by injecting, well, just sticking a screwdriver on the wiper of the volume pot, if we can find the limit thing, that is. Yeah, it's one of those slider things. So if I set the current limit to 100 milliamps, should be able to cope with that. Let's have a look, see what's getting hot. So I can't really hear much. Pretty sure, yes, it's cutting down on current limit at the moment. We're down to 6.3 volts. Just double check that is volume control. It is, yeah. Yeah, we're down to 6.2 volts. It's where we want a thermal camera in it, so wind it up a little bit and see what's getting hot. Okay, the volume pot is just literally a slider. Let's see if we can find out where that is. So just touch. Don't seem to have any output at all. Normally if you touch the connections on the volume pot, which is here, you would get a noise. So we've got no no audio on it. So it's 7 volts. We should get some noise out of it, really. It's absolutely dead. So we've either got a transistor shorted or a capacitor up the duff. Right, let's can't really see what I'm up to there, can you? Let's have a look back at the schematic in a minute. C73 looks a bit puffy. Yeah. I mean, normally you would get a little bit. But we don't appear to have any audio at all. Let's just have a poke around with the old signal tracer a minute. I'm just trying to see if I can find a decent ground connection. We've got a bit of corrosion there on the back. Oh, hang on. Whoa, hey, hang on. There's a bit of corrosion here, and I've just wiggled it, and the wire's just literally fallen off. Where are we? Oh, I'm zoomed in hellish far. Okay, there we go. Yeah, this wire here, I mean, literally that is corroded off the board. If I move that, that's just come right off. So let's desolder that a minute. Speaker short, it could be Tony. Let's just get this this wire replaced, and then I'll have a look at the speaker. So you can see the wires actually come right off of there. I've just got it in place there so I know where it came from for a minute. But it might not have been what's causing the problem, but it certainly needs sorting, whatever way we go. Let's find a bit of black. Want some black. I don't have a lot of hookup wire. I really struggle to find hookup wire. I've got various bits and pieces of it, but not a lot. Ah, okay, that should do it. That looks about the same. In fact, that's slightly bigger. I'm going to replace the wire because no doubt it's corroded all the way through. And we've also got a little diode in there as well, so I want to check that while I'm in here. It's just good shout, Tony. Yeah, it could be the idiot diode, couldn't it? The reverse polarity one, because I mean this is the negative in from the battery compartment. So that's the diode in question there. You can just see that. So I just want to remove the old solder. The old sucky suck gun. There. Let's put a bit of flux on that because potentially we've got a bit of corrosion there. Let's solder that one back on. Okay, and onto this. So say this is the wire coming up from the battery terminal, and it looks like that's corroded as well because there's a big lump of crystalline. Let's get some of this out of the way. Yeah, that diode is directly across it. I mean, end of the day, that diode should be alright, but you never know. What we'll do is we'll get rid of this horrible old solder, if I can get it to melt. Maybe not. Yeah, it's gone horrible, that has. Where's my picker thingy? It could be a bit of that was lying across a couple of the joints, maybe. Because it's gone really crystally. See that bit there? It's gone all powdery. So that's our wire from our battery compartment, our ground wire. So I'm going to have to put a bit more fresh solder in here before I can get rid of the old knackered stuff. Diode looks okay. Oh, yeah, it's quite badly corroded. Okay, let's just lift the leg on this diode a minute. Let's give that a bit of a clean up. Bit of isopropyl. So we've got all this debris everywhere. Okay. Right, diode. Let's turn that off for a minute. Derek, good afternoon, mate. How are you? Scott from Walking the Hound. Jay, how are you? You have the original Toshiba TA8132 IC. You want to make 3-band radio, but in its circuit diagram on pin 1 they writed FM-IF in. So what type of circuit can make on FM-IF in pin? Low on solder and flux again. Right. That's cleaned up. Let's test this diode. We use the peak just so you can see a bit easier, really. Okay, it's sent as a Zener diode. 5.3 volts reverse voltage, 5 milliamps. Forward voltage 0.68. Green is the anode, blue is the cathode. If you can see that or not. So we've got a Zener diode in there, have we? I suppose that would be a lower voltage drop, wouldn't it, than a normal one. But saying that, isn't 0.6 a normal sort of diode drop? Yeah, we're okay, Derek, thank you. Been cleaning the chickens out this morning. This afternoon even. Playing with your Lin turntable, I take it then, are you? Yeah, Jay, I'm not really sure. Obviously there's a few things involved in an IF circuit going into the chip, but I'm not sure how much of that IC does the IF, because some of those are like a radio in a chip. You don't need a lot of circuitry. You'll need to look at the you need to have a look at the data sheet for that chip and see what it does, mate. Afternoon, Nick. You've been out visiting. Yeah, I think mine's got a Lin basic arm on it. I've got a Lin deck. So we've got a reverse voltage of 5.3. And a forward voltage, that's a forward voltage drop, I assume, of 0.68. Seems quite high, that, for a Zener. I thought Zeners were around about 0.2, 0.3. I'm not sure. So let's have a quick look at the schematic while we're here. And I wonder which one it is. It's not D11 because that's on the top of the board. It could be this D12 here. Just have a look, see if that's on the ground line or not. Yeah, I'm wondering if it's this D12 diode up the top here. D11's on the other side of the board. That's not a Zener, that's just a standard diode. I mean, that's between the positive and ground, but I wonder if it's got any spec on this one here. So it's an EQA, I don't think it'll let me select that. An EQA 0105T. EQA 0105T. It's a Schottky diode, according to that, is it? Let me make sure I've got that right. EQA 0105T. Yeah. I mean, this is just adds, so it's unlikely that that's, yeah, strange. It doesn't actually give that. Does it list any parts information? No, it doesn't. So it doesn't tell me what the Zener voltage is on it. Okay. Well, it is still showing as a diode. It's not open, but it might not be the correct value now. That's the trouble. Oh well. Oh well. Oh, hello, Ken. How are you? You looked it up. Where did you find it then? A 0.7 volt Zener. So that's probably right. It was 0.68, I think, wasn't it? So let's go with that as correct for now. And let's solder back up this big mess here. Because say it was all a bit of a yucky mess there. So let's get all this resoldered. It's a nice flux on everything. Whatever that is there, that's not soldering that bit. That's too badly corroded. This little pin here. Just gonna rough it up a bit. See if we can get a better solder to it on it, a bit more flux. Bend this diode back in there. Get my nice new wire in there. There we are. Let's oh, hang on. I could better put the battery wire back on, am I? That would help. Hopefully it's not. It's fairly corroded. Let's snip that off a bit further. I might need to replace that wire. Yeah, it is quite badly corroded, that one. So look where that goes to. Oh, it would go right the way. Oh, God. Okay, gonna have to replace that whole wire, I think. I mean, the wire basically goes around here. It comes out through that gap, comes in around and joins up to this end, which again is badly corroded. Yes, it comes around to here, look. That's a little bit dodgy because there's not a lot to solder to there. Okay, so you can just about see the negative terminal there, and that's actually what it's soldered to. And it's all gone crystalline. It's just literally glued in there by the looks of it. Yeah, okay. I'm just picking this glue off of it. That wire's going to have to come out. We're going to have to stick a new wire in there because that's badly corroded. I mean, I don't think that's causing the issue because we're not using the battery supply. We're going straight in on the power jack into the main board. So we're actually bypassing this battery wire, but still got to be done. Ugh, this glue is horrible stuff. There it is. I don't know what it's called, but it's like it's a bit like Evo stick, I suppose. It's like some sort of contact adhesive. I used to use it in cars years ago. Stuff called sealer stick. Bear with me, people. I'm just trying to get rid of a lot of this old glue because I ain't going to be able to get my wire back in there else. That little peg is deciding it doesn't want to be in there anymore. So God knows. You call that glue Bison? Tea time. Stick your voltmeter across it. Okay. Right, so there's a little tiny gap through there that the wire goes through. So let me get a bit more of my wire. Goes through that gap there. Comes up, in around there, onto that mess there. But there's not a lot there to connect up to. Let me have a drink of Guinness a minute while I think about it. Might have to have some hot snot back in place of that, Benji. So yeah, this bit here, I'm a bit concerned about soldering to this because it's right on the plastic and it's gone all crystalline. We've got this lovely glue attached to it as well. Did have. You think that terminal would protrude a bit further through there, wouldn't you? So as I could physically get at it. Let's take this off. Let's just pop the speaker off as well before I stick me. I'll stick something through it anyway. Let's get these bits out of the way. Let's get a bit tidied up here. Get a bit tidier. Snip that off, we don't need all that wire floating about. That Zener sounds like a stabilized supply for the radio oscillator side. I mean, I've got other 0.7 Zeners here. Just need to see how to get onto this lash up they've made here. I really don't know why. It looks like it's moved up a bit. It looks like it's pushed up. Yes, it has. Okay, that's better. Ah, now we're getting somewhere. Right. So hopefully, if I just pop a bit of solder on this. It's badly corroded, that is. Job to get any solder to stick to that as it is. It's just see if I can okay. That might do it. Let's give it a bit of a file. Got to be careful because this is all plastic here and it's obviously getting it really hot. It's going to melt it. This already is melting it. That come back. Okay. What I'll do is I'll cut it a little bit long and then I'll be able to wrap it, put it through the hole, threading a needle, potentially. And then can't really see what I'm up to, can you? Get you in on the overhead camera. I'm going to wrap it back around itself. Ugh, it's horrible and messy, this. So this is thicker wire than was in there originally. So I just wrapped it around like that. Let's see if we can get a nice big blob of solder on it without melting all the plastic again. Unlikely. Let's pop the iron temperature up a little bit, give it a bit of a fighting chance. Isopropyl to cool that down. Right, that's got a good connection. Just need to dress the wire around and we're getting there. Yeah, the brown glue is not good stuff. Right, I'm just going to see if I can get this wire dressed back in. I don't think it'll go back where the other one went. Because it is bigger. Bigger. Yeah, it's bigger. No, it won't go back there. So we need to put some hot glue in there anyway to hold this this post in place. Just hit that with a load of isopropyl to flush it through because there's a lot of flux and all sorts of nastiness in there. Corrosion. It's better. Right, hot snot gun. Let's get it out. Sounds like the chickens are in laying now in their nice clean coop. Right. Let's let that heat up for a second. So I don't know whether we've had a leaking battery in that in the past. It's strange that the corrosion is only in one place, but this whole wire has gone brittle inside, not making a great connection. So this could be the solution. I don't know, unlikely, but it could be a lot to do with it. So let's cut those old pegs off because we don't need those anymore. Cut the old nasty glue off in preparation for the new hot snot. Needle's very fragile, so I need to be careful I don't knock that. Okay, I think we're getting up to temperature. Not quite there yet, but not far. So basically this hot snot is holding this terminal actually in. Not a great design, is it? But right, here we go, hot snotting. Let's push that right down into the corner. Bit wetted finger, tidy it up a bit. Taking care not to eat the hot snot. Just let that go off. Yeah, your packaging boxes are the business, Benji. Okay, nearly there. Just this one piece here to snot in. This is the big snot, the big finish. Just a wetted finger does smooth it off a bit better and makes it look a bit nicer. Not that you can make hot glue look that nice really, but that should hold it very nicely, thank you. As usual, loads of it all over my workbench. Leave that out of the way to cool down. Right, yeah, that's that's well and truly secured that side of the board. Just got to reconnect this wire. Comes up in around there. Well, I didn't expect to have to do that, but then, you know. Arrow's the best. Yeah, you are right, Doug. The original, really. I have somewhere got an arrow glue gun, but I don't know where the hell it's gone. It's one of those incredible disappearing things that one day you've got it, next you haven't. It's not particularly pretty, that, but you know. No stragglers. Okay, right, that's done. It's done. Let's get some of this stuff cleaned up. Get the bench a bit clearer, and I'll reconnect it to see if that's any different. At least it's another job done. Surprising at how many tools you've got to get out just to do a simple little job like that, isn't it, really? Right. Good. Good to go. Let's zoom you out a little bit. Let's get the speaker back in. Connect it back up. Actually, we're going to check to see if the speaker was shorted. Let's just do that a minute. So I should be getting, it's a 4 ohm speaker, so I should be around about there on it. Should hear a pop as I touch it as well. No. 3.7 ohms, so yeah, we're thereabouts. We are thereabouts. Okay. Let's get some power on it then and see what happens. Okay, it's gone into current limit. It's drawing even more power than it was before now. Let's bump that up a fraction. It's drawing 330 milliamps. So still a very high current draw on it. 330 milliamps. So that's all good. It's all connected in. Still too much. Afternoon, Les, how are you? And Ganesh. Ken, how are you? Vinegar breaks most glue down. Wash off with alcohol. Yeah, I've not put any vinegar on it at the moment, Ken. I think it is the leaking cap. Something will be getting hot, yeah. But what? What get hot? Yeah, the transistors there are getting hot. Yeah, that one's getting very hot there. And these two are. Oh, and that one is. Okay, so these three transistors here are getting very hot. That's T. Can't quite see that one. T 14, 15, 14, 15, 16. Thirteen, 14, 13, 14, 15 and 16 are all getting very hot. Let's have a quick look at the schematic. Whew. Touch the IC. There's no IC in it, Khaled. It's all transistorized, mate. There is no ICs. Let's have a look. So this is all in this regulator circuit, really. Let's get the picture-in-picture off. Okay, so the transistors that are getting hot are these four here. So 13, 14, 15 and 16. So 15 and 16 being the output transistors are getting really hot. So we can check this diode here, D11. Oh, that's that's that funny little one though, isn't it? That seems to be attached in underneath here. I still think it's the that C84 personally. I think it's that one, but just going to pull those a minute while we're in here. It's difficult to test them with it actually in the circuit. get a picture of that. So yeah, all these four are getting hot. Let's pop that speaker back out of the way a minute. Let's get those two caps done and go from there. Got a nice bit of hot glue stuck to the bench now, as is normal every time you touch the stuff. So I'm just taking a picture of where these wires are because you bet your life as soon as I try and desolder it, it'll all come apart. Remove, hang on, I think it would work from power input forward on this one. Look at the schematic. Remove the 470 output cap just in case it's leaking through the speaker. Has the current dropped? Take the transistors out and check them. Right, lots of things to try. Yeah, so C82 is the cap attached to the speaker, and that is the one that we're going to take out. So we're taking out C82 and C84 now. They're both coming out. That's the plan. Are they marked on the board? Yes, they are. It's jolly nice of them. My nice new wire's in the way now as well. Right, so these are hot snotted again, and they're hot snotted together, great, with whatever nastiness they've used. Let's try and oik them out. God, that's horrible stuff. There's one. I assume you're on the right camera. Hot snotted to death. Look at this one now. Will he come out? Or is he going to play hard to get as well? Ah! Dear oh dear. Right, let's turn that off. Let's have a look at those two a minute then. Let's have a look at these two then. So we've got 1000 microfarads. What do you think this one's going to be then? Do you think this one's going to be great? No problem? Or do you think this one's going to be absolutely shot? 1000 microfarads. You can have a little guess at that one in a minute if you want, while I get a top up. Analog is better than digital. Yeah, digital's... When you say digital, I hope you're not talking about DAB. You mean like digital, digital readouts, brimming full of ICs, etc. And yeah, that's, you definitely agree with you there. It's better. Oh, hang on, there's a wasp in here now. Get out. How did that get in here? It'd be just my luck to get stung by a wasp, wouldn't it? Get out. Try it then. Take that one. Get off. It's after me beer now. I'll have to go get the executioner. This is not that one that's wrong. How about this one then? 470 at 10 volts. Oh, it's going to do it anyway, so no problem with that one either, look. 470. It's not those. It's not those, people. That's a surprise. I was banking on it being that main smoothing cap across the supply. Cut the rest of this horrible glue off. So potentially that's a good sign, because those are the two sort of hardest used caps probably in the circuit, and if they're all right, the likelihood is that the others are as well. But obviously no point putting those same ones back in, so we're going to change those for a couple of new ones. So 1000 at 16 and a 470 at 10. that's a bit big. Hmm. $470. I'm just trying to find suitable caps here. Let's have a look. There's a 470 at 10, so we've got that. $10 470. It doesn't look like I've got a small enough 1000 to go in there. Hang on. What have we got there? What's that one? Oh, that's 15 microfarads at 400 volts. That's no good, Graham. What's that one? 1000 at 25. 1000 at 16. That'll go in. 1000 at 35. That's too big. Check here. No, that's all higher voltage ones. All right, okay, those two will do. Make sure there's no conductive glue between the terminals. I don't think there is. Gonna have to get our thinking heads on next, because I think we could be looking at a dodgy transistor. But is that the buzz in the speaker? I don't know where this wasp has gone. It might be laying on me, ready to bite any second. Because I do get bitten quite a lot by insects. They love me. They love me. Can you hear the chickens out there? They're doing their laying now because they haven't been able to while we've been trashing their house. Right, I'm just going to put this one back in. And then I think we need to maybe do as Nick suggested and get the transistors out for a little look-see. Get out. There we go, tucked in nicely. Put that wire back on there. Okay, that's that one. And this one. Okay. See, that one there's got glue going right through that one. There's my external speaker. Let's connect it back up again, just for a laugh. No, 400 milliamps, way too high. Exactly the same with no speaker connected, still 400 milliamps. Right, any other suggestions a minute then? Stung on a comfort break. Just catch up with the chat a minute. You're backing up memory cards whilst watching, multitasking. So we just tried it without the speaker there, Tony, and it's still drawing the same. It's drawing about 400 milliamps now. So Doug is thinking bad transistor or bad diode. Yeah, agree. Runaway. Thermal runaway. So it could be that diode, couldn't it? D11 knackered. Could be shorted. That's underneath this nasty bit of stuff here. Let's turn that off a minute. So let's see if we can find D11. So that's that. No, that's a transistor. Okay, so the diode. Let's just get this on diode test. Let's check that D11 diode now. So D11 is in here. So we've got 0.58 one way, let's go the other way. 0.69. Okay. Let me think, is that right? Let's have a quick look down there a minute, actually. Try that again a minute. Let's just check this transistor in here then. Where is it? Base is there. Base collector. Base emitter. Collector emitter. That transistor looks okay, but junctions on that one. I'm just poking around some of the transistors here a minute, people, so just bear with me a second. That's that one, base, BCE, that's that one, base. That one doesn't seem right. That's potentially dodgy. Where's the other one? Right next to it there. There's a base on that one. Base is there. Oh, hang on, that's base. Yeah, that one's okay. This one. Okay, no, that one is alright. I'm just buzzing out these transistors a minute. Let's just try this one here. Base collector emitter. Seems a bit spread apart, is that definitely it? That's a 3. It's there then. That one seems okay. All those transistors, I can't find a short on any of those. Try these over here. No. I don't get nothing on that one at all. I think maybe just base is down there. Excuse me people, I can't see the chat for a second. Base to collector. No, that one is alright. Hell, I can't see anything wrong then. Oh dear, apart from potentially that diode, which seems to be acting a bit weird. So we've got 0.58 volts that way. 0.69 that way, so there is a difference. I don't know. Whew. Right, let's have a look. Let's catch up. Johnny, how you doing, mate? Sheridan, how are you, mate? Can you show the diagram again? Yes, I can. Bad bias, drive trannies. Terry Blackman is saying eat Marmite, it keeps the bugs away. Output transistors. Tony, you're chickening out. You need to fix some dinner. No worries, Tony. Thanks for joining us, mate. I've just done that, Ken. I've just been right the way through. Quick check collector emitter on transistors in circuit for shorts. I've just gone through them, but I will quickly check just the collector and emitter. I'm pretty sure I've just been all the way through those and done them all. But let's do it again, just so as you know. Let's start with I can't get at that one. Base collector emitter. So this is collector emitter. Certainly haven't got a short there. Next one. BCE, so collector emitter is these two. Oh, actually no, there. Get no short there. Just can't get at these. So the next one, collector emitter. No, that was okay. And this one, collector. That one's okay. So that's all four of those that were suspect. There's another one there, T12, hiding away. 12. It's going to be that one there. Yeah, I don't think we've got any shorts on the transistors. Check that the other way around. Okay, let's not just check these again. So there should be a junction there on the collector and emitter on these two. No, so it's okay. Just me. No, it's just me. I mean, that one there is, I don't know if it's just me, but that one doesn't seem quite right. So let's get a collector emitter. Seems high, 1.3. Let's try the other way. Nothing. T10 is potentially suspect. Let's pop that one out a minute. Let's pop T10 out. Yeah, lift the diode. I'm going to pop T10 out and I'm going to lift the diode. That's the next two. Sorry about all the beeping, people. Let's get another beer in because I'm getting a bit dry. So we've got something a bit different this week. We've got Galactic Milk Stout, but alcohol-free. Big Drop Brewing Co. So this is going to be interesting. I don't think I've ever had this before. Most alcohol-free bitters and stouts are pretty foul, to be honest. I haven't found one that I like yet, really. I've tried them all, but some of them are disgusting. Let's try this one. There's the microphone. Yeah, still good. So I'm going to pull T10. Sheridan wanted the schematic up again. Let's do that for you, Sheridan, a minute. So that's the area that we're looking at the moment, which is the power supply section, the amplifier section, really. And I'm coming back to T10, which is not even in this circuit. T10 is up here. T10 and 11. It says we've got an LED there somewhere. Well, I don't notice an LED anywhere. Oh, yes, I do. Yeah, it has got an LED. That's the point. The LED could be shorted, I suppose. So basically I haven't really got a decent junction on the collector emitter on this one. But it is PNP, that one, isn't it? I get confused as to which way around they are. I think that's NPN, this is PNP. But we've got two other back-to-back diodes in there as well. And we have got an IC, look. We have got an IC hidden somewhere. An AN7218, so apologies to our friend there, trying to think who it was now. Said about the IC. Jay, I think, was it Jay? Well, Khaled, it's Khaled, isn't it? Khaled, so it could be the IC, couldn't it? Output coupling capacitor. You mean this one here, Les? C82, because we've just changed that one, and that one was showing okay. So we've changed C82 and C84. No change on that. Obviously there's a lot of other caps in there that could be causing the same. This one here is connected to ground, C77. This one here is connected to ground, C79. And this one coupling the volume pot into the amplifier section, potentially. And this one up here, C73, is going to ground. So there's 1, 2, 3 there that are suspect. 73, 77 and 79. Okay, that's not too bad. Did I just have the schematic on the screen then or not? I should have done. Let's try that again. It's definitely on the screen now. So we've got these two here, T17 and T18, they're in the power supply. Definitely this one, T18. Where are they two then? T17, T18. Let's have a look for those. I can see that IC. Oh, it's starting to get a bit scary now if I look at those, because that means taking this plastic piece off, which means taking the dial cord off. I don't think we want to be doing that at this stage. So I wonder where those two are, T17 and T18. Got a layout here somewhere. T16. 13, 14, 12. Hang on, where are we? T18 is there. Where the hell is that to then? I wonder if that's in the other circuit and not in this one. Yeah, I might be barking up the wrong tree there. That might be in the other radio, not this particular version. Yeah, okay, T18 and T17 are not populated in this radio, so it can't be those. They're not populated in this radio because it's not got the built-in power supply. See, I can forget that altogether. Scrap that thought. So it could be one of these caps still. But I'm going to pop this this transistor up here, T10, because it's not measuring right in circuit. It might measure fine out of circuit, but who knows? It could be a shorted IC, couldn't it? Of course. An AN721, is that 7218? And no voltage markings on the actual IC, which is a shame. Let's quickly check the layout, see if there's any voltages on the layout. No, nothing on the layout. So we'll have to look at the data sheet up on that. Oh, hang on, we've got some voltage here. Yeah, we have got a voltage chart. Look. Okay, so we've got voltage charts for all of these, so really in theory we could just power up. The problem is it's drawing too much current and something's going to go pop if I leave it turned on, if it hadn't already. Right, let's get back to it. Output coupled cam. It's a DC coupled amplifier, so any transistor could cause a problem. Nigel's saying top of screen. Right, let's pop this transistor here out. T10. Is it, or was it T11? I'm confused now about which one. It was T10 that wasn't reading right in circuit, so let's just pop that out. Let's make sure we get that the right way round, so that is facing that way. That's self-explanatory. Right, let's try this one. This one is, I believe it's 2SC458. Doesn't sound out of this world. Let's pop that on the old transistor tester. Yeah, NPN 369 HFE, no problems with that one. It's good. T10 good. It's about time I just printed off a schematic and just marked what I've done on here, because I'm going to get stuck else. It's just one component I'm sure gone on this. It could be that IC. So it could be that someone's connected it up backwards again, as is the norm. Couldn't it? Could be. That chip is the AM, FM, IF amplifier. Okay. Rob, Rob, how are you? Rob is saying, as Nick said, the audio stage is DC coupled, so any of the audio transistors or their biasing will upset the whole circuit. Now there's no audio output at all, Les. Just so I can get a little sort of pop, but I can't, even touching the volume pot, I can't get any noise through the speaker. Right, so let me just have a look at the other caps that are connected to ground a minute. Let's have a look. C79, so we're looking at biasing. Okay, biasing. D11, we were going to check that next actually, weren't we? Doug suggested lifting a leg on that to test it. It's a bit of a messy diode, that one. Let's try lifting the leg on D11 then, we'll just test that. There goes my hot air gun. So can I get more? D11 certainly looks like it's something to do with thermal runaway, but you shouldn't really get that. Not so much in a transistor circuit. Let me get my light back down, I can't see anything here. Right, okay, come on Graham, sort yourself out here. Right, should be able to check it on that. Yeah, that is a diode junction. That diode is okay. The diode is okay. Just tack that one back in. Before it jumps back out, because it's okay, right, C79's coming out now. C79's coming out now, this one here. I'm just going to check this one. If I can find it, I think it's there. Right, 220 microfarads, 6.3 volts. $220. Is this the one? Place your bets. 220, 6.3 volts. It doesn't look to have vented. It's not got a bulging top on it. Yeah. A fault in the chip would not cause the output transistors to get hot. Good call. Yeah, yeah. Chinese dentist, 230. 230. Right, what do we think then? 220? I've just got that multi. 230. 230. Very good. Let's push the button then. $215. It's not that one. Let's put another one in. 220. 10 volts. No filling required. Okay, there's another one. What's the other ones in here? C84 we've done. We've just done C79, C77, 77 and 73. So 77 and 73 are both connected to ground. C80. Now that C80 does control the biasing if these two, possibly. C80, we haven't done C80, have we? C80, where's that one to then? Let's try C80. I think it's that one. It's got all this blimmin' glue on it again. I think it's this one here, but this one's the one that's got all the glue all over it. Let's pop that one out and have a look. Again, the cap doesn't look bad. Let's try it. Floppy! How you doing, mate? More than likely a transistor, but testing in circuit can be misleading. Mike, how you doing, mate? Let's try this one then. Ah, hang on. Hang on. Could be dirty leg. Let's just go down a bit further. Oh, okay. I got all excited then. Just me not connecting up very well with the leads. So that one's fine, 216. These caps are not bad. I don't think it's a caps. I think we're right going down the transistor route. Got another 10 volt, 220. 220 at 10. There we go. I just want to eliminate the capacitors, because normally it is capacitors, isn't it? But it's not always the capacitors, but 8 out of 10 times it is. Okay. There is a couple others I just want to do because they are connected to ground. Hi Milo, how are you? Live with a cup of coffee. Very nice too. We're down a bit too low now, aren't we? Let's get the camera back out again. You can see what the hell I'm up to. I don't know what I'm up to, so I think C73 was another one. Yeah, C73 is definitely connected to ground. And that's also in the power supply circuit right underneath all of this lot. Great. I've just pulled all that out, look. It looks to be right underneath all of this lot that I've just all resoldered. Oh well. Let's take it all apart again. Try and find out where this one is connected to, but this has got all this snot all over it as well, all this potentially conductive glue. Oh, God. Nasty stuff in it, so that could be causing issues. Right, that's most of the snot out. Should have done that one when I was in there, really, shouldn't I? But, you know, hindsight and all that. Is that one leg of that cap? Yes, it is. So where the hell's the other one? Got to be right underneath there then. Right, is it that one? All the snot all over it. 220, 10 volts. Let's try it and see. It's not that one. I mean, it's a bit low, but I don't think that's going to be causing it. Just pop another one of those in. Right, I'm just going to reconnect all this lot again, all my wires. Which are looking a bit gnarly now because they've been disconnected so many times. We're getting there though, people. We are getting there. We're eliminating it bit by bit. Hi Dis, hi Jeffrey. Looks a bit rotten, you'd hammer it then put it in the bin. Could be, Jeff. Still without the bishop, yes. Yeah, unfortunately, Dids, we're on Galactic Milk Stout, which to be fair actually isn't too bad. I could drink that. That's not bad. The radio's getting a recap. It is in a roundabout way, isn't it? Caps seem good. What make are they? They are TK. Japan. Japan's always good, isn't it? So yeah, they do seem all alright, to be fair. Right, let me get in amongst all this lot here. What's going on? Just need to make sure I've got this wire in the right place as well, you know. I'm not convinced. Right, let's put down a bit of solder on the board here. We'll get our wires soldered back on. That one first, and then this one. And finally, poor old diode, which has been messed about. Right, that's that cap done. And that one ain't bad. What have we got there? C61 and C56. So the only two left in the output. Let's have a look. We'll get there. I'll get there in the end, Doug. You're right. C77. Where was that one to then? Because again, that would affect the bias. C62, C61, C80, C77 is tucked in underneath there. Just pop that one out a minute. That's going to be difficult to get to, that one. Going to be actually extremely difficult to get to, but you know, if it was easy, where would the fun in that be? Right, C77, this is a different make now, 10 at 16 volts, and that is this one here. So again, we're still in the amplifier circuit. That's on the bias of T12 look. So again, if that was leaking to ground, that would upset the bias of this one, in theory. Where's the popcorn, Adrian? How you doing, mate? Jeffrey's going to hammer it and put it in the bin. Right, 10 at 16, let's try this one. 10 at 16 is a popular failure for caps, and this doesn't look a very good quality cap compared to the others. Saying that, they are made in Japan. I don't know where this one's come from. Okay, that one's all right as well. It's got a fairly high ESR, 1.6. It's a bit high, but the capacitance is okay. The ESR is a bit high on that one. Can I get another one in there though? It's going to be a bit of a fiddle. Yes, get in there. All right, just burn that one onto the board. Turn the iron down a bit. Okay, that's that one done. Right, final look through the caps then on the schematic. If it was a capacitor to ground short, transistors would not get hot, really can. So what you're saying is I'm barking up the wrong tree. C79, I think we've done that one, haven't we? 77. Yeah, I've done C79. C77 I've just done. C73 we've done. C74 0.22 at 16 volts, unlikely. So where do we go next then? Do we I mean I've done the caps that I would say would likely cause an issue. So let's look back at this circuit again. So 13, 14, 15 and 16 were all getting really hot. We've checked D11 is okay. I think we've done C80, haven't we? Yeah, we've done C80, that's okay. That was checking out all right. D11's checking out all right. Resistors, unlikely. We've got a pot in here, which is bias adjustment. I mean, unless someone's twiddled that, that is down on its minimum. So do we start checking transistors? Shall we check the output pair first, T15 and T16? One's a 2SD787 and one's a 2SB738. One's a PNP and one's an NPN. Or do we go back and check this driver or pre-driver? This is AF amp. Where to next? I suppose we check the outputs and work our way back. Yeah, we've got to take them out of circuit, Nick. Definitely. I mean, they're looking all right in circuit, bar that one that I tested, but pulled it out of circuit. It was fine. So we'll pull the output pair first. Let's go back in number. So we'd do 16, 15, 14 and 13 in that order. Let's find T16 then. It's this one here. Let's pull that one. Sounds like my desoldering tool is clogging up again. Right, okay. So T16 is out. T16 is out. So it is indeed a B738. Yes, that. Jeffrey. Replace every single component and repair done. Michael, now come on. That's what we're going to do. Now these, I don't think I've got any of these for sure. That one's fine. No problems with that one, so we can eliminate that one. T16, good. So normally you check the voltages, but the problem is it's drawing too much current. So okay, next one. T15 is that gammy one with all the gumph on it from the diode. There's me thinking this is going to be a nice simple fix that we can just do quick and then get on with the Hacker Herald, but it's certainly proven to not be the case. So this is a D787, which is a 2SD787. Where are you looking at? Yeah, you're looking at this still. Okay, fine. Mike! How you doing, mate? C92 maybe short. C92. Oh yeah, I see where you are. Good thinking, Mike. Again, it tends to be the very last thing we look at, isn't it, in transistor sets, is the non-electrolytic caps. But I have had it once before. Okay, yeah, D787, yeah, okay, right, let's test this one. Yeah, good. No problem. Measure's fine. That's going to be a pig to get back in, that one, isn't it? So Just going through the transistors in the output stage at the moment, Mike, but I will check what you've suggested in a minute. Might have hit it on the nose, you never know. It's a blimmin' awkward to get this one in though. It's awkward to get in, and it's awkward because it's connected to that diode with that horrible heat transfer paste. Okay, they've checked out alright, so the next one is done 16-15. Let's check T14. Let's get that one out, that's in there. Says that my desoldering tool is blocking up again. Let's do that again. T14 out, and the transistor tester. Good. We're running out of options, people. We're running out of options. Good turnout, yeah, very good, Doug. Okay. We are really running out of options now. So what's the next one? So let's just refresh your memory which way we're going with this. We've taken out 16, 15 and 14 so far. They're all checking good. So T13 is the next one. Just find that one. It's there. Let's pop that one out. Fix anything, how are you, mate? Could have checked the transistor before plucking it out. I've already been through and tested them all. Fix anything. I've checked them all with the diode tester, and they all checked out all right. But like people say, it's better to take them out and test them, really, I suppose. Yeah, I did check them all earlier, just for junctions. There was one that was a bit dodgy in circuit, but when I pulled it, it was fine. That one's good. We're really running out of options now. I mean, one thing I will say about the IC, if you look at some of the Roberts sets that I've repaired that have been reverse polaritied, nothing works at all if that IC has been reverse polaritied. It just pulls everything down. But you don't normally have a high current draw on it. That's the only clue, really. And welcome, Mr. Fix Anything, as well. I don't think we've seen you before, so welcome, mate. Good to have you on board. Any suggestions? Happily looked at. So, okay, that's T13. We want T12 is the last one, which is back here. T12 is particularly awkward to get at, as it would be. Got to be just there, right next to this foam pad. Lift R54 isolate board if still high current before this. Ah, welcome from Pakistan, Mr. Fix Anything. Great to have you on board, mate. Ken is saying lift R54 to isolate the board if still high current before this. You bet that R80 bias is up too high. It could be, Les. It could be, because it is wound all the way, but as far as I'm aware, the guy's not messed with it. Checking what I've actually pulled there, because this is all very bum. That's the resistor. We don't want the resistor out. It's back from that. Yeah, you could well be right there, Les, because it is wound all the way one way, if you know what I mean. So let's try this one. This is probably the last one to pull. I don't think there's anything. That's all of the transistors in the output circuit pulled at this stage. So if this is good, then we've really got a bit more head scratching to do yet. Fine, no issues. Oh, typical, isn't it? Absolutely typical. So here's the output circuit again. Let's get rid of me. So what have we done? We have done C84, C82. We've had all of these transistors out and they all check fine. We've checked D11, which checks fine. We've done C80. We've done C79. We've done C77. We haven't done C74, I don't think, which is 0.22. But that's off of the volume port into the first stage. But I mean, that's just blocking DC, and it's not. It's going to let the audio through. I suppose it might not let the audio through if it was open circuit, but then that wouldn't cause us to have a high current. Even if it was shorted, it wouldn't cause high current, would it? I'm not sure. I've got to get this one put back in circuit, and then I'll leave that up for a second if anyone wants to study that and make any suggestions as what we can try next. Mike has suggested checking C92, and someone else said take out one of the resistors to isolate the circuit. Is it R60? R58, I can't remember now. Just get that comment back up again. Ken was saying lift R54 to isolate the board. Where's R54? Up here. Okay, we've got some good suggestions coming in, so I see what you're saying, Ken. If we pull R54, that's isolating part of the circuit. And Les is saying this 2K pot here, which is the horseshoe skeleton pot, turn that one so it's at its highest resistance. I'll leave it up for a minute. I think I'm on that, aren't I? Yeah. I'll leave that circuit up for a minute just while I pop this transistor back in. Oh, yeah, particularly awkward to get back in. They've poured wax on it for some reason. Yeah, great. Right, just pop that one back in and then I'll check the chat. Okay. Right, let's have a look at this pot that Les has mentioned then. What can we get on there to test that? Let's pop the LCR meter on that in a minute. Turn that desoldering tool off for a minute. Oh, it's better. Yeah, I think that's where we're going, Sheridan. We're going to have a go at R80. And Les is saying adjust it so the pot is at its highest resistance. So I'm just going to connect the LCR meter up to it, pardon me, which is easier to clip on. What's the main problem? It's we've got no output from the radio, and it's drawing too much current to fix anything. It's drawing well, it was about 200 milliamps originally. It's going up. So I'm just going to connect onto R80 a minute. Now let me have a look at this, because there's 3 connections, only 2 are connected. So the 2 that are connected are that one there, and if I can get on it, is that connected directly to that link? I think it is. Okay, so this is measuring that that resistor. Let's get you back. So this is the variable resistor, which is R80. It's a 2K variable resistor. So Les is saying to have it at its highest settings, but it's not far off of that, is it? It's, no, let's get the blue pot tool in there. Spanky, how you doing, mate? 24 hours in A&E? No way. Flipping heck, I bet that was a bit painful, mate, wasn't it? What do they do? Give you something to break it up, Simon, or did they? So if I go that way, it goes back to 363, then wind it all the way up as it was. It was 1.8, so it's 2 there. Look, I've just about got it at 2. So that's the highest resistance. So are you saying, Les, that the highest resistance should be the lowest current draw? Because to be fair, it wasn't far off. It looks like someone's had a twiddle of that before. It was about there, I think. So let's and that was obviously in circuit, but we know which way is the highest resistance and which is the lowest. So let's connect it back up again. I'm just going to plug my speaker in there. Let's get everything off of the bench that's likely to short it out. I mean, it might be that we've cured it, you know? Unlikely. Unlikely. You've got painkillers until it passes. Have you got anything to break it up, Simon? Sounds painful, mate. Sounds painful. Right, okay, let's connect this thing back up again. I mean, I am definitely connected the right way round, aren't I, on my power supply? Let me just double check that. Center pin is positive, yeah. Yeah, no, I'm connected the right way round, okay. Right, let's see if we've... Okay, so it's drawing 320 milliamps now. Let's just twiddle this. It actually goes up higher if I turn that. So no, we're drawing 320 milliamps, which is a lot. And I've got an external speaker in at the moment, which is probably the wrong ohms for it. Let's go. Let's pop you on the screen cap, and I'll pop you onto the power supply. You can see what it's actually drawing. It's all very well me telling you what it's drawing, but it's nice for you to see for yourself, isn't it? We'll just get all the gumph out of the way. All my wires. So there's our power supply, 7.4 volts. Fire in the hole. 310 milliamps on FM. Exactly the same on the other bands. Just pop that off because that's too high. It's only 3mm, they said. It will work its way out. It was painful in the extreme, but on the mend now. Good to hear it, Simon. You start checking voltages as 300 milliamps is unlikely to do damage. The problem is, Sheridan, is all the transistors are getting really hot at that. They are getting really hot. Let me just check the speaker ohms as 4 ohms. What ohms is this one? I'm not sure what ohms this one is. Let me just check the speaker ohms just to make sure. This might be 8 ohms, which isn't going to make a lot of difference. It would just make it quieter, but yeah, that's an 8 ohm speaker. Would that make a lot of difference? Probably not. Let's just pop the original speaker back in, see what the current draw is with that a minute. Just going to clip wire that on. Certainly a bit of a mystery, this one, isn't it? Probably something stupid that'll bite us in the backside, I expect. So I'm just connecting back up the original speaker, which is 4 ohms, just see if that changes the current draw. No, exactly the same. Yeah, that's getting way too hot, that output. That's getting way too hot. Okay. So let's go back to the schematic a minute, and I'll just pop that camera off the power supply. Back down onto the radio, on the dreaded radio. I can, but the problem is, welcome, Gier. The problem is if I limit the current, it drops the voltage. So if, for example, I limit the current to 500 or 100 milliamps, it actually pulls the voltage down. It pulls it back to about 6 volts. But yeah, those transistors are getting really, really hot. Let's look at what Mike suggested, which is C92. Mike has suggested this one here, C92, could be causing an issue if that was shorted. Les is just saying the same thing. A blown IC if every transistor gets hot. See, that's what I was thinking, probably. It could well be that IC has had reverse polarity up its back end, and it's dropped it out. But I don't know if we've got an idiot diode in there. So let's see if we can pull C92 and check that a minute. That was Mike, Mr. Racing Demon, suggested that. So which one is that then? Is it that one there? C83, C81. 71, where the hell is it? C81, C75. Should be here in my face somewhere. But I can't see it. Oh, C82. I'm looking for C92. That's 83. 81. 75. Well, I am blowed if I can see that. C83, which is up there. I can see that one, but I cannot see C92. It should be right there, unless it's on the other side of the board. Yes, it is. 223, is that likely to be it? Yes, it is. Right, let's just get you down on the board. I was going to say I could not see that, but it's down here on the other side of the board. Look, it's that little monkey there. That little monkey. That's what it is. Rob is saying the IC is capacitor coupled to the audio stage, so will not heat up the transistors. Yeah, for tiny costs, everything should have an idiot diode. Definitely, Ralph. I agree totally, mate. Okay, Rob. Yeah, you know your stuff, mate. I'm not going to argue with you. So we're still looking in this output. Let's pop this. Let's pop one leg of this and test it then. Pop a leg of this one. In fact, I mean, we could test it like that, couldn't we, really? With that one disconnected and see if we've still got our problem. Yeah, we've still got our short, or possibly we've still got 320 milliamps with that one disconnected, so it can't be that one, can it? But let's check it anyway. Let's pop it on the LCR meter. It's a good call though. Right, where are you? So it should be 22 nanofarad. $18. It's not far off, is it? But it's not. It certainly isn't that causing the issue. So we'll pop that one back on. It's just a sort of decoupling cap, is it? Okay. Now, it was suggested that we lift R54 to isolate the circuit and test that. C92 has the 40 ohm speaker across it. A 4 ohm speaker across it. Yeah, no, you're right, but C92 is fine. I've just disconnected that and we've still got the short. So we could lift a leg of R54, which is over here. It's a bit confusing with the board markings, but it's that one there. Let's just do that with a bit of desoldering braid rather than turning all that lot back on again. The bench is looking a bit of a mess now, people. We've still none the wiser. We've not got any closer to this. There's one there. It's just a process of elimination at the moment, really, more than anything. So we've lifted R54, look. So let's jump back to the screen. Am I sure I'm the right way around with the DC input? I don't know, Les. I don't know, mate. It could be that, couldn't it? So we've lifted this one now, R54. So that's isolating the amplifier from the rest of the circuit, I believe, isn't it? Because that's going up now into the IC. So if we isolate that, that's going to 100% show us that the problem is in the amplifier if it still happens. Now, Les has just said, am I sure I've got it the right way round? Well, I'm not. Les is the answer, but I'm sure I have, but I don't know. I'll go with any suggestion. Right, let's try that again then. Okay, we've still got 30 milliamps with that disconnected. So it definitely is in the amplifier, isn't it? Or I'm connected backwards with my power supply. Are we checking something that's not broken here? Could it be that simple? I will shoot myself, I think, if that's the case. I will go and gibber in a corner somewhere. Let me just connect that back up. Right, okay, so we're still on we're still on the schematic. So this is ground and the center pin is positive, and that's the way I've got it connected. You know, this is our positive here, isn't it? I mean, I'm not cracking up, am I? Where are we? Just trying to see what you're looking at. Yeah, okay. So yeah, this is the center pin, which is connected to the positive side, because the battery makes and breaks the power supply. The jack plug breaks this connection and puts the power through that way. So it's breaking that one. I mean, I can connect it up to the battery terminals as well, just to make 100% sure. Let's do that as well while I'm at it. Well, we're here. So let's have a look. Where are we? Well, that was negative there. And our positive is there. hang on a second, what's going on there then? Maybe I was wrong. It's now only drawing 20 milliamps. What? It can't be right, surely. Am I cracking up, people? Yeah, you could all be right. I mean, to me, that is center pin positive. But I mean, I've just got it connected now with the battery connectors. What am I on about? Not with the battery connectors. What are you going on about, Graham? So I've got it connected with these at the moment. I'm just making 100% sure I'm in the right connectors. Was it that one? Oh, hang on. No, that was definitely the negative. It's gained into that one. They're just gained together. So let's connect that up again. Well, that's drawing 20 milliamps now. Connected like that. Okay, let's There could be a problem with the power supply socket, I suppose. Let's just pop that current limit right down on its minimum and reverse the polarity of the power supply. And that's not working now. What's going on then? That isn't working now, so the diode's doing its job. It's blocking the power from coming through. Bizarre. I don't know what to say about that. Let me have a think. So that's gained across to there. That's a negative. That's negative going there. Dodgy battery terminal there. That's definitely where our wires are connected. So we're connected there and there. So why would it be causing a problem when we're on the power supply and not on the batteries then? Unless the switch has gone in that power supply, maybe. A dodgy switch, I suppose. Oh, hang on. Hang on, no, I think I might have just cocked up there. I think I might have dropped a boo-boo because I might have connected the wrong leads up. Okay, let's try that again. So current limit on minimum. Let's connect them up the other way round. It's gone into current limit. No. What do you know? I must be cracking up because that to me looks like that is the negative and the center pin is the positive, but it's backwards. I've got the speaker connected, Les. So we've got no output still, but let me get you up onto the power supply again. Look, this is doing my head in now. Yeah, it could. You could well be right. So where are we? Let me just get my screen back up so I know that we're on the right screen. Okay. So now I'm connected. You can see I'm connected backwards. I've got the negative into the positive terminal and vice versa. So if I now turn the radio on, it's drawing 20 milliamps, and it's not gone out on current limit. No output still. Oh, hang on. Yes, there is.
He was starting to rebuild. On one visit, soldiers were handing out toys to young orphans.
Oh my God.
Jeremy reunited one of the soldiers, Adam Eaton, with one of the recipients.
We've come eat Ramin Paikar to kick about in crowd. With his neatly groomed beard and broad, confident smile, Ramin looks older than his 27 years. He's coming out here.
I don't know what to say. I'm just going to go and hide in the corner, I think.
Ramin says this green, well-kept sports ground was just a dusty yard at the time, and the modern kitchen at his dormitory used to be much more basic. Ramin showing a photo of Adam's soldiers handing out toys.
I had the volume down minimum, that's why we couldn't hear it just now.
8 years old.
They played football. Next to me. Light me up like an element. You say you got to get some caught up in the charm.
Wow. Oh dear. What a pain in the back body, isn't it? Eric, you're doing my Sweden. He's human. Oh dear. Thank you, Derek. I'm too embarrassed to even put the camera on there. What can I say? Now, I think potentially the issue was that broken wire on the negative, because this radio has come to me because it's not working. So we've probably fixed the fault, but I'm trying to fix another fault that's not there. So if you remember that wire that was badly corroded on the negative, I think that's probably what stopped the radio working. We fixed that, but we've got this over voltage, not high current draw. But why on earth? I just can't get my head around that circuit diagram. Yeah, I think it's double goat, isn't it, for that? I think we've got a double goat situation now. Because I've got both the goats, so it's going to have to be a double goat. Oh my God! Got there, Mike, but what a plonker! Remember to adjust the bias. Bias is set as it was, Nick. Set it back to 1.89, wasn't it? Something like that. But let's have a look at the bias adjustment on the instructions, if I can make head or tail of it, because it's all in German. Has it got the bias measurements on there? And that is going to be R80, which is here somewhere, R80. I don't think there's any mention of the bias adjustment, Nick, in the instructions here. I don't know if any of you read German, but yeah, I don't know if any of you read German, but I can't see. It's R80 is the adjustment for it. That's FM IF 10.7, AM IF 460, AM oscillator, so that's the RF, FM oscillator, and that's all I've got. Obviously R80's over here. This is the bias adjustment. Let's just fit this to page a minute. Spin it round and just zoom in on this just to see if there's any mention of the bias adjustment on the actual schematic. So here's R80 2K. It doesn't. There's no mention of the bias adjustment on it anywhere that I can see. R80 is there. No, there's no mention of that. I mean, I've got it set pretty much where it was, to be fair. Can you remember the Can anyone remember the actual resistance that we had on it originally? Okay, so resistance is 2 at the moment. Well, it was 1.8 something, wasn't it? Actually heard that in the speaker then. Let's give that a little squirt. It's a bit it was 1.8 something. I'd have to rewind the video to find out what what it was originally. It was 1.8 something, wasn't it? I think it was pretty much. Yeah, I'll have to rewind the video and see what it was set at, and then just reset it to the same resistance. That's all I can do, because there's nothing on here anywhere that I can see that that tells me how to adjust the bias on it or what it should be. Normally there's a link that you pull out. I'm just looking to see if there's a link in the. Can't see a link there that you're supposed to pull out to check the bias. Alright, well, there's a couple jobs I've got to do. I've got to reset that, so I'll just rewind the video later and I'll work that out for myself. Whew, well, what a nightmare. I award myself a naughty cream bun for getting me to switch my power leads over. 1.89, was it, Multi? I think it was about that, wasn't it? Yeah, not enough beer. I think you're probably right, Multi. So Gia is saying you just don't see how reversing the polarity should make a lot of current to pass through those output transistors. Yeah. I have recapped it. I've sort of, well, partially recapped it. I've certainly recapped the output stage, which is beneficial, isn't it? And I have rewired the negative part of it, which I think is what's probably killed it originally. Rewired the negative wire, put a fresh wire in. In fact, a couple fresh wires. Oh well, you know. I don't understand that schematic. I think we'll have to get Les over to explain that schematic to me, because I can't see how I was connecting it wrong. I mean, unless my power leads the wrong way. No, my lead's the right way round, definitely. It's a mystery. I'm just going to check my lead a minute that this isn't lying. And that there is indeed center pin. Yeah. My lead's wired the right way wound. Oops, wired the right way wound. No worries, Rolf. Catch you soon, mate. Thanks for popping in. What can I say? As I say, I think we've got the fault in that we had a dodgy connection on the negative. It was broken. I fixed that, replaced a load of caps in it. It's taken me 3.5 hours. And, I don't think we can charge the customer for 3.5 hours labour, can we really? But there you are, sorted. What else do we want to do? I think it's probably a good place to leave it now, isn't it? Really, I mean, there's no point really me starting on the shortwave Herald again now, because I've got too much to do on that. Really, that's going to take a live stream on its own to get that one finished and up and running. But yeah, what a game! What a game! What have I got in new? Spanky, Simon has sent me some mini discs, so thank you very much, Simon, for that. I've got those on the stairs, on their way up the stairs, and I shall be getting my mini disc player going, and also the mini disc player that Derek very kindly let me have. We'll get that up and running. I've also got to sort the Sony Walkman out, haven't I? That's got issues with the little leaf switches. It's all in the game. You could have been launching rockets into space, and look how many of them blow up upon launching. Well, we haven't blown anything up, Theo, luckily. But I still can't understand how that's possibly wrong, unless they've drawn the circuit diagram wrong. Keep the dial cord safe. Yeah, you are right there, Doug. That would be the last straw, wouldn't it? If the dial cord snapped off. Don't say that, Doug. Put it all down to experience. Yeah, I want to get my head around what has gone on with that schematic. Unless it doesn't say, does it, which way round it goes? But I've zoomed into the schematic just now. I mean, I don't know who agrees with me that it should be center pin positive. It should be. You know, it should be center pin positive. Can anyone enlighten me as to why? So here's our mains connection. This is our input. So we're putting the plug in there. The negative side of the plug, which is the larger part of the jack plug, is connecting to the outer here. And the center part, which is positive, goes in and makes contact with this one. Which breaks that contact for the batteries, and then puts the positive down around here, down through here. Then back up and around that way, and that's positive. I just can't for the life of me get my head around this. Why? Either they've drawn that wrong, or, well, I don't know. Anybody got any suggestions? I would love to know that, because I swear that is the correct way round. There's not Nick. No, it just literally says 7.5 volts, and that's it. There's no markings. Giveaway radio at the end of August. Thank you, Mike. Great stuff, mate. Catch you soon. So we look forward to the next giveaway. I've still got to fix that bush that you sent, Mike. I want to get that one done. I know you're a bit disappointed it got damaged and beat up a bit in transit, but I want to get it fixed. Definitely want to get that fixed because that's a lovely old radio, that one. Was it, what was she called? Was it Ethel or Elsie? I can't remember now. It's one of the two, wasn't it? Put it down to experience yet. You found the PSU. Oh, that'd be great, Derek. There's one other thing that we could check, and that is, let's have a look, see if we can find the a Grundig. I keep forgetting how to spell Yachtboy. Y-A-C-H-T. .300 user manual. Yes, I did. There we go. Owner's manual. Let's have a look in the owner's manual just to see what it says. No, that's the PE. So this is the one with the digital front on it. That's the wrong one. PE 300. No, that's the PE again. 300. That's it's a U101, isn't it? No, that's the PE. PE. No, there's nothing. I can't see, there's no documents there. I mean, there must be a user manual for the Grundig Yachtboy 300. There must be. No, that's all the schematics and everything. Schematic 1A, 1B. Board. Is that drawn differently? I'm not sure actually. Yeah, no, I can't find anything on it. I cannot find anything on it at all. I've got a little mini-me up in the corner of that. Even the chickens have gone quiet. It is recapped and tested. Still working. Well, you're still working, Rob, or the radio's still working? Elsie, it's Elsie, okay. Elsie's was my grandmother's name, Mike. Or my nan. There we are, people. So that's it for today. Thanks everybody for joining today. It's been a bit of a journey, bit of a strange one really. Trying to find a fault that's not there. Although there was a fault because it's come into me non-working. And I think I'll have to pop a little sticker on the side saying like center pin negative. I think it's a misprint in the schematic somehow. But there you go. 189, Ken. No worries, mate. I'll rewind it later. I'm on 1.9 at the moment, so I'll rewind the video later. I'll just set that bias back to how it was. 76 watching. No, we've had 99, Spanky, at one stage. We had 99, I think. Thanks for the trip down the rabbit hole. To be fair, though, it's been good fun following it along and trying to work out what was wrong. It's just Les. Les is the voice of reason. Is the power lead the wrong way around? Well, yes, it was. I still don't understand why, because it was correct according to the schematic. Bonkers. Everyone loves a mystery. Oh, I've got loads of stuff coming through Google Chrome now that I've turned Chrome on. So cheers, people. And say, if you're not subscribed, remember to hit that subscribe button. And if you want to see what I'm up to in the week, then you need to pop on Patreon and have a look. Catch you soon, people. And as I say, I'll catch you on next Sunday, unless I can get myself sorted and come on Wednesday. I'm not sure yet because I've got to go hospital on Tuesday, so it really depends how that turns out. So bye for now, people, and catch you soon. Thanks for joining me.